Hello again. Last time we learned a little bit about what distributed Weka is and a little bit about the MapReduce framework. In this lesson, we're going to install distributed Weka and start to use some of the components that come with it. So let's get started. Okay, so here we are in Weka's package manager, which I'm sure you're all familiar with by now. What we're going to do here is scroll down a little bit in the package list, and we are going to install distributed Weka for Spark. And here it is, just down here. Okay, so if I click install with this one selected, it asks me, or it tells me that I'm going to install the following packages: distributed Weka for Spark, version 1.0.2. We click yes, we click OK, and then it tells me that in order to install this, we need also to install distributed Weka base 1.0.12. So at this stage I'll click no because I already have this installed, and we won't show it installing at the moment because the download is fairly large for distributed Weka Spark and it'll take a little while, and I already have it installed. Okay, once you've installed distributed Weka, you need to make sure that you restart Weka so that the packages, or the newly installed packages, are loaded correctly. So the main way to interact with distributed Weka is through the knowledge flow environment. This allows us to chain together processing components in such a fashion that a given component will not execute until the previous one has completed executing. So it's also possible to use distributed Weka from the command line, but the graphical user interface provided by the knowledge flow is a very convenient and easy way to edit the sometimes many parameters that are involved in setting up a distributed Weka job. So let's verify that our installation of distributed Weka has proceeded correctly. Alright, so in the Weka knowledge flow environment, you can see that there is, on the left-hand side in the design palette, a new folder called Spark. If we open this up, we should find that there are a bunch of new components available to us. In particular, we have something called an ARF header Spark job, we have a Weka classifier Spark job, a Weka classifier evaluation Spark job, and several others as well that we'll discuss shortly. The distributed Weka for Spark package also comes with a bunch of example template flows. If we look in the templates folder, which is accessible from the templates button up here in the toolbar, we can see a bunch of entries that are prefixed with the word Spark. These are all example flows that we can execute right out of the box. They don't require a Spark cluster to be installed and configured because Spark has a very convenient local mode of operation, which allows it to use all of the cores in your CPU as processing nodes, if you like. So we can execute these particular example flows straight away without any further configuration. They are ready to go. Before we start running distributed Weka examples, I need to introduce the dataset that we're going to be looking at. So we're going to take a look at the hyperthyroid data. This is a benchmark dataset from the UCI machine learning repository. The goal in this data is to predict the type of thyroid disease a patient has, using input variables such as demographic information about the patient and various medical information as well. So in this dataset there are 3,772 instances described by 30 attributes. A version of this data in CSV format without a header row can be found in the distributed Weka for Spark package that you installed just before. So if you browse to your home directory and look in Weka Files, Packages, Distributed Weka Spark in the sample data directory, you'll find it there. The data in ARF format is also included with the Weka 3.7.13 distribution in the data folder. So you can also load it up into the Explorer and take a look in there. So why don't we do that now? Alright, so here we are in the Weka Explorer. Let's open the hyperthyroid data. So if we browse to the Weka installation directory, program files here, Weka 3.7, and in the data directory, we can see the hypothyroid data. So let's open that up. So as mentioned before, there are 3,772 instances in this data set, and we can see the attributes here. So we have the age and sex of the patient, and we have a bunch of attributes related to various medical information. Down at the bottom is the class attribute. So you can see there are 4 different class values here. So by far the largest class in the data is that of negative. So those are patients who don't have hypothyroid or thyroid disease. And then we have 194 cases of compensated hypothyroid, 95 cases of primary hypothyroid, and only 2 cases of secondary hypothyroid. All right, so that's the characteristics of the data. We can now return to the knowledge flow and start executing some distributed Weka processes on this data set. Before we do so, it's worth spending a minute or two to explain why we're going to be operating on comma-separated values, CSV, files without a header rather than ARF. So systems like Hadoop and Spark split data files up into blocks. This is to facilitate distributed storage of large files out on the cluster, and also to allow data local processing. So this is where the processing is taken to where the data resides. So rather than move the data around, we take the processing to where the data is. So within such frameworks like Hadoop and Spark, there are readers, as they're called, for various text files and for various structured binary files. These readers maintain the integrity of the individual records within the files, so they know where the boundaries between records are, and they don't ever split a record in half. If we were to use ARF within such a framework, we would need to write a special reader, due to the fact that ARF files, as you know, have header information that occurs at the start of the file. And that header information provides details on what attributes are in the data, their types, and legal values, and so forth. Now, because the data file gets split up, only one of the blocks or chunks of data out on the cluster would have that header information. That is why we'd have to write a special reader to handle it. So distributed Weka for Spark, as it stands at the moment, operates just on CSV data, simply because there are readers already available within Spark and Hadoop for dealing with such data. All right, here we are back in the knowledge flow environment. Let's execute the first distributed Weka job in the list here. So the create an ARF header job. Load that in, make it a little bit larger here. So we'll use this one to verify that everything is installed correctly and running properly. Now the goal of this job on the hypothyroid data is to analyze that CSV file and produce some summary statistics, and do this in a distributed way. At the same time, it collects all the information that's necessary to create an ARF header, and it stores this. And then any future jobs that we run can make use of this ARF header information straight away and not be required to analyze the CSV data a second or third time before they can run. So what we can do is go ahead and execute this and see how it runs. First of all, make your log area, switch to the log from the status area down at the bottom here, and make it a little bit larger so that we can see what's happening in the log, because Spark generates a lot of log output, and there is information about what it is doing, and you'll see any problems that occur in that log as well. So we have just one job that's going to be executed here, the job to create the ARF header. And we'll just run this right now and make sure everything is working correctly. Later on, we'll take a look at the parameters for the job, and I'll explain a little bit about how it's configured. So up here in the upper left-hand corner of the knowledge flow, we can press this play button and start the flow running. As I said, we can see a lot of information being dumped into the log here. Most of this is coming from Spark. Now the job has completed. We can see here it says successfully stopped something called a Spark context. Alright, so what has this job produced? Well, we can see here in the flow that we have a dataset connection coming out of the ARF header Spark job to a text viewer. So if we open up the text viewer and show the results, and I make this just a little bit larger here so that it fills the screen. We can see that, as the name suggests, it has created an ARF header for the hypothyroid data. In fact, it's an ARF header on steroids because there is some extra information in here. What we can see at the top is standard ARF header information. So here's all our attributes, just like we saw in the Explorer before, all the way down to class here, where in this row here we can see all of the values of the class attribute listed. Now, below this is a bunch of additional information that we've added into this header. So the way that other jobs are programmed when they make use of this is that they can either access this additional information or remove it and use a standard ARF header. So what we have in this additional information is a bunch of summary statistics that have been computed on the hypothyroid data running in parallel in the Spark environment. So you can see that for the age attribute here, there is summary statistics that have been computed on that. So we have a count, we have a sum of squares, we have minimum and maximum values, and we have a mean, because this is a numeric attribute, and a standard deviation as well. And similar for other attributes. For nominal attributes, it computes a frequency distribution. So down here in the class, the summary attribute for the class, we can see the class label for each of the values of the class, and followed by an underscore and a number, and that number is the count for that particular class label. So the ARF header job has computed a header for us and a bunch of summary statistics. The next time we'll take a look at how that's configured, and we'll also look at running some other distributed ARF jobs as well. So in this lesson we've covered getting distributed Weka installed, our test dataset, the hypothyroid data, the data format processed by distributed Weka, and we've taken a look at a distributed Weka job running on Spark to generate some summary statistics and an ARF header for the hypothyroid data. Next time we'll dig in a little bit deeper and see how these things are configured, and we'll run some classifiers on the hypothyroid data. So until next time.